All right, chapter 2. We're going to do, it's really like 2 parts in this chapter. We're going to focus on the first half of the chapter on polynomials. Okay, today with an emphasis on linear and quadratic polynomials. And then we'll open it up to bigger, higher degree polynomials on the block. And then we're also going to do rational functions. And rational functions, that'll be new to you. So polynomials is going to feel very, old school because we did it in Algebra 2. But rational functions we didn't. But we did those last chapter. Now we're going to do them by hand. It's the ones that have those asymptotes that go like that, like the graphs that kind of go off to infinity. Okay, so here we go. We're going to do first a little introduction. And then part B will be focusing strictly on linear equations, and then C will be quadratics. Okay, so what is a polynomial? Well, polynomials look like this. F of x equals a sub n x to the n plus a sub n minus 1 to the times x to the n minus 1 plus dot 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 all the way down to a sub 2 x squared plus a sub 1 x plus a sub 0. All right, that's horrible, right? I know. It's really bad. So that's a polynomial. It could be really long. You could have a quadratic, a quartic, a cubic. Remember all those words that you learned in Algebra 2? Now, what do all these mean? Well, the a sub n, those are all real numbers. Okay? These are all real numbers. And the n's all have to be non-negative real numbers. So whole numbers. Non-negative real numbers. Okay? So if you're going to be a polynomial, you know what polynomials look like, I hope. So something like this is a polynomial. Y equals 10x cubed plus 3x squared minus x plus 4. Okay? That's a polynomial. All right? It's a cubic. It has 4 terms, so we call it a polynomial. It has 3 terms, the trinomial, binomial, monomial, all those things, okay? Something that is not a polynomial will be like the rational functions that we're going to do at the end of the chapter. F of x equals x plus 3 divided by x minus 5. That's not a polynomial, okay? Something else that's not a polynomial, g of x equals 9x to the negative 4 plus 3x minus 2. Okay, that almost, it wants to be a polynomial, but it's not because of that negative 4. Okay, your exponents have to be positive numbers. And then also you can't have things like this. H of x equals the square root of 3x squared plus 1. There's no or minus 1. There's no square roots in polynomials either. Okay? Polynomials are very basic. They have numbers next to exponents. Okay? All right. So let's focus on linear functions. Now, we're not going to do too much because you have already done linear functions this year in chapter P, right? Didn't we do standard form, slope intercept, all that stuff? Yeah, we did all of that. Okay. So for a polynomial that's linear, they write it as y equals ax plus b. It's the same thing. Y equals mx plus b, y equals ax plus b. And let's just go ahead and remember how to find the equation of a line really quickly. So number 1, let's say that I have f of 2 equals negative 4 and f of negative 3 equals 7. And this isn't going to be pretty. That's okay. And we want to find the equation of the line that goes through those points. Okay? So lines are considered to be polynomials, and we're just going to quickly find the equation of this. Now, this might look weird because we haven't had it look like this before, but basically what this means, if you have f of 2 equals negative 4, that means that x is 2 and y is negative 4. It's a point on the graph, okay? F of 2 equals negative 4. Like on your test, when you had to do f of negative 5, you had to go over to negative 5 and tell me what the y value was there. So this one was -3 is 7. Okay. All right, so first thing you're going to do to find the equation of this line is you want to find the slope. And like I said, this is going to turn out kind of ugly. We're going to have an ugly number for slope. We're going to go 7 minus -4 over -3 minus 2. So 7 minus -4 is 11. Yeah. And -3 minus 2 is -5. That's pretty gross. Yeah. Why did I pick such gross numbers? I don't know. I really don't, but I did. All right, so here we go. Let's go ahead and put this into point slope form. I'm just going to use the first point, 2, -4. So we're going to go y plus 4 equals 2. Oh, no. I messed up. -11/5. Got ahead of myself. X minus 2. Okay, so far so good. We remember point slope form. We use it a lot. You're going to use it in calculus a lot. Use it in this chapter a little bit. And then go ahead and distribute, because we want to get this into a polynomial, standard form for polynomial, which is slope-intercept form. So -11/5 x plus 22/5. Okay. And we need to subtract 4 over, but let's go ahead and subtract 4 in terms of fifths. So 4 is what, 25ths? And so we get y equals -11/5 x plus 2/5. Bless you. Pretty gross. Yep. Okay. And that's it. By the way, they might ask you, what is the degree of this polynomial? What's the degree of all linear? 1. All slanted lines have a degree of 1. They might ask you, what is the leading coefficient? The leading coefficient when it's written in standard polynomial form, it would be -11/5 in this case, which is gross. That's okay. All right, you feel pretty good? Yeah? I don't think we need any more of those. Okay, what we do need to do, though, is we are going to do a scatter plot problem, okay? I know, you did this last year. Some of you didn't like it last year. But the second time through it, it's going to be a little easier because you might know where the buttons are a little more. So, yeah, go ahead and get your calculator out. You're going to definitely need your calculator for scatter plot. Yep, this is what the Algebra 2 kids have been working on for the last week. So let's remember a couple of things. A scatter plot basically is just some data points, and usually they're going to be in some kind of a correlation to each other. They might look like this, which would be a positive linear correlation. Okay? You might have something that looks like that, okay? And that would be a quadratic correlation. So you'd want to find a quadratic regression for that. Later on in the year, have you ever looked up the tide charts? Like you want to go down to the tide pools in Laguna Beach or something, and you look up to see when the low tide is, okay? And the tide charts, they do this kind of a cool thing. There's high tide, there's low tide. That would be a really good sine wave. We're going to learn trig, like a sine wave that comes through. So this might be, they call it a sinusoidal. And that's actually on your calculator. They give you a sine wave. It's really cool. Okay, so what we're going to do right now is we're going to do we're going to do linear correlation. Sometimes positive, sometimes negative. When you want to find out how good your fit is, like, oh, should I have done a line? Should I have done a quadratic? Should I have done a cubic? It's going to depend on the R value. R, you want to get it as close to plus or minus 1. For a positive correlation, you want it as close to 1 as you can get it. For a negative correlation, negative linear, it would be plus or negative 1. Quadratic, you're looking at the R squared. The R squared for quadratics. And a sinusoidal, I don't know if they give you an R or not. I forgot. Okay, so here we go. I'm going to give you some data, and we're going to enter it all into our calculator. And I think there's 7 points. So we have a cereal. Did you have cereal this morning for breakfast? No? Anybody? Yeah, what kind did you have?
Honey Nut Bunches.
Ooh, I love that one. That's really good, yeah. My son, he eats Reese's Puffs, like the peanut butter and chocolate. Yeah, very healthy, very healthy. Okay. So let's say that cereal is being sold at the store, and the price per box I don't know if you pay attention to prices of food. You probably don't because, you know, your mom or dad probably shop for you and you don't have to worry about such things, but I do. So the box is $2.40, and this is going to be the number sold the week that it cost this. So the box of cereal was $2.40, and 38,320 boxes were sold that week. Okay, now it's going to go up 20 cents every single week. So the next week it's $2.60. Well, guess what? You think more people are going to buy it? No, less people are going to buy it. So this week, 33,710 people bought the cereal. $2.80. 28,280. Okay. $3. It went up to $3, and $3. It was 26,555 people bought it that week. Then it went up to $3.20, and you're wondering how many points are we going to do? We're going to do 7. 25,530. Okay, 2 more. It went up to $3.40 for the box of cereal, and 22,170 people bought it. And finally, $3.60, and 18,260 people bought it. Okay, so we got all of our data points, and what we're going to do different parts. So our first part A is we're going to sketch a graph of the scatter plot. Okay, we're going to sketch a graph here. Give yourself a window. And then we also want to say what the window range is. We want to find out what our window range. So here we go. Let's remember how to do this. You have your calculator today, I hope. So you're going to go to your calculator. Put it right here. And we're going to go to Stat, Edit. Okay, you want to be on L1 and L2. If you're not on L1 and L2, you want to scroll over to L1, L2. If you don't have an L1 or an L2, please let me know and I can fix your calculator for you. Sometimes you accidentally delete it. Okay, so let's say that I want to clear all the entries. You go up to L1 because you might have some data in there from, I don't know, whenever you did this last. You can go up to L1, never delete your list because you know what? If you delete them, guess what you do? You delete them. Yeah, I know, crazy, huh? You can clear your list by hitting Clear, Enter. And I just cleared all of L1, which is really dumb because I had the data points in there. So, anyways, okay, so you're putting them in, 2.4. You don't need to put 2.40. Your calculator doesn't care about that 0. It's not a race, but it is. Right, Ben?
Right.
Not a race. There you go. Okay, and I'll let you catch up. I'll wait for you. Sounds like an accounting class going on. It's pretty fun. Sounds like tax season. Anybody want to be an accountant when they grow up? A number cruncher? Yeah? Sounds like a good job. I like my accountant. His name's Rick Dykstra. Do you know him? Yeah. Does my taxes for me. He gives me a pretty good refund, too. And it's legit. Okay, are you there? Yes, yes. Okay, so now we're going to go to y equals. And you want to clear anything that you have in y1 or y2. And we need to turn our plots on. Okay, so you go up to plot 1, hit enter, and come back down, and your plot should be on. Now, the thing about these data points is we need a good window. If I hit zoom 6, there's not going to be anything there. Because this is 240. This goes all the way up to 38,000. So the best thing to do is hit zoom number 9. Do you remember that button, zoom 9? Zoom 9 is zoom stat. It gives you the perfect window for your statistics in your calculator. Okay? Anybody's not working? Need some help? No, we're all good. If you have like something that it looks totally off, you have a point out of place and all the other ones are all bunched together, you made a mistake. You need to go back in and edit and find out what your point is. Yeah?
Can you go over that really fast?
Yeah. Go to y equals and then clear anything out and go up to plot 1 and turn your plot on by hitting enter and then hit zoom number 9. Zoom 9.
It says error.
Error. Okay, let's go ahead and what you're going to do is you're going to draw a sketch on your paper of your work. It's not plagiarism, you're copying your own work down. Yeah, that totally looks cubic to me, but we're going to pretend like it's linear. Actually, it's a pretty good line too. It is. You'll see. And then check out your window range. Let's go over to window. And the range that your calculator picked for you was $2.28 up to $3.72. Okay? It's really important to list the range so that I see what your window is. And then for the Y's, I didn't give myself enough room, but the minimum is $14,849 and it goes up to $41,730. So that's the Y range. Okay, so let's now, part B, is to find the line of best fit. The trend line. Find the line of best fit. And we're going to figure out how accurate this line is. So we want to write down what R is equal to also. Okay, so we're going to write Y equals the whole MX plus B, all that stuff. So here we go. Go back to Stat. And then go over to Calc. And we're going to go to number 4. See all of those? There's a quad, a cubic. If you keep scrolling, there's natural log, exponential, logistic. There's the sine one. That one's really cool. Anyways, but we're just going to pick boring old 4, okay, len reg, and then hit enter. Some of you might have to hit enter through some prompts like L1, L2, store, stuff like that. And there you go. And that's a pretty good line, right? So our line is negative 15,358.9x. We'll just round to one decimal place. It's fine. And then plus 73622.5. Okay. And so that's going to predict how many boxes are going to be sold at a certain price. There you go. And then write down what R is. R was negative 0.98. Negative 0.98. That's pretty good, huh? Do you want to see what the cubic one is? Yeah, I do too. Hold on, real quick. Calculate the cubic. 0.99. See, we knew that. Yeah. Okay, anyways, so let's go back. Calc number 4. Let's pretend like I didn't do that. There you go. All right, so now let's go ahead and we're going to put this line on our calculator. And there's a few ways to do that. There's actually 3 ways to do that. Number 1, you go to Y equals, and then you just type it in, right? Negative 15,358.9x plus 73622.5. And then you hit graph, and it should show up, and that's your line. Okay? Yeah? Yeah, just go to Y equals and manually type in that equation of the line.
Can't you do something with bars?
Yes. Or, there's another way. Hit clear. Go to Y equals. If you want to do it this way is kind of fun. You go to vars. Down to number 5, statistics, and then over to equation, and then choose the regression equation, whether it's linear, quadratic, whatever, it'll put the regression equation in for you. And then you hit graph, and there it is. Okay? The third and final way is, I can't do it on my calculator, but you guys can. Thank you. I need to get me one of these. All right, here's the third and final way. If you go to Stat, if you have a newer calculator, and you go to Calc number 4, and instead of hitting enter all the way through, it says store regression equation. And you can store that in Y1. If you hit alpha trace, all the Y's pop up. And you can choose Y1. Don't you love that, Bobby? Mm-hmm. You know who taught me that? Eustace. Do you know who Eustace is? Yes! He goes, why don't you just do this? And I'm like, why don't I? Because I don't have that calculator, but you do, so you should. That's really good. And you hit enter. Yeah. So I'm going to clear this out for now. So you go back to Stat, over to Calc, and when you do your line, you do store regression equation into Y1. So you hit the alpha trace button, and all the Y's pop up. You can put it in Y1, you can put it in Y2, Y3, whatever. I'm going to choose Y1, calculate. And then when you go to Y1, it stores it in there for you.
What was the second way again?
Bars. I don't have that option, though, unfortunately. So I do bars. So good, though. All right, and then you draw your equation of your line. There's your line. Perfect. Okay, and then part C. Now you get options here, too. We are now going to predict the sales. Predict the sales if they raise it all the way to $4 a box. People are not going to buy that cereal. Okay? Now there's two ways to do this. One is the good old-fashioned way, to just plug in f of 4 into your equation up here, okay? The other way is to trace it on your line. If you're going to trace it on your line, your window has to be big enough that 4 is going to fit in there. Right now, my window, do you see what it goes to? 3.72. So if I want my window to be bigger, I'm going to go to Window, and I need my x max to maybe be like $4.25 instead, okay? And when I graph that, now my line has been extended to where x equals 4. When you do go to trace, though, it's going to try and trace the points. L1, L2. You want to trace your line, so you need to get on to your line. See, it's blinking. Do you see it blinking at that point up there in the corner? And if I hit trace, it would go to all the points. I don't want to do that. I want to arrow down, so now I'm on the line. Do you see how I'm on the line now? And then you can plug in 4, hit enter, and it'll tell you how many cells there are. Okay, or if you don't like that, just take 4 and plug it into your equation that you have right here. 4 goes in for x, and then it'll tell you that 12,187 approximately people will buy the boxes sold. Okay? So, but sometimes you have to change your window if you're going to do it on your line like that. Now, do you like it a little better this year? Maybe a little bit? Okay, last part. We're going to move. Part C, and we're going to focus on quadratic. Okay. Now, we've done some quadratics already this year, and we've actually done them with the thing that we're going to do right now. So we're going to talk about vertical freefall motion again, okay? Where s of t is equal to -1/2 gt squared plus v sub 0 t plus s sub 0. Okay, we did this earlier this year. We had a -16 out front, -16 t squared, but now they put in a -1/2 gt squared. And because we're going to be either in meters or feet, it depends, all right? So let's talk about what each of these things is. S of t is the height. The height's going to be either in meters or feet. T is the time in seconds usually. Okay. We already know that v sub 0 is the initial velocity and s sub 0 is the initial height. But what's that g there? Do you know what g is? G is the acceleration due to gravity. Some of you knew that because you're physicsy people. Acceleration due to gravity. I never took physics. I think I would have liked it. It's weird. I have a master's in math and I never took a physics class. That shouldn't seem right. That doesn't seem right to me. Okay, acceleration due to gravity. And then there's one more. There is the velocity equation, v of t. V of t is -gt plus v sub 0. Okay? And when you get to calculus, you're going to see how these two are related to each other. This is the derivative of that one, but we don't know derivatives yet. Bobby does. He's like, yeah, derivatives. Okay? And calculus makes this problem so much easier. Even Mr. Edlin says so. He loves to use calculus in his stuff. All right, so let's do a problem. Velocity, by the way, is the speed. So if I know this equation right here, and they ask me, what was the speed at 2 seconds? And you can find the exact velocity at that time. It's the instantaneous velocity. Okay, so here we go. Suppose that, last one, number, what do you want, 4? 4. Suppose that we take a rubber ball and we throw it up into the air and then it comes right back down, okay? So the equation that they get for this rubber ball, because what they do is they actually, they use the thing called a CBR, where it calculates the time and the height. It's really cool. And they have a whole data thing, and they got this equation from the data. S of t equals -4.676 t squared plus 3.758 t plus 1.045. Okay, so there we go. and it's an excellent fit. They got the r squared to be 0.999999. All right, so, and it also says that the height is in meters and the time is in seconds. Meters and seconds. So what we're going to do is we're going to do a couple questions. First question we're going to do is we are going to find the maximum height of the ball. Okay? And when they did this, they did it super fast. It took less than a second for the ball to go up and come back down. Okay? So then t is going to be, I'll give you a range of this. T is going to be from, let's do 0 to 1.5. Okay? And then let's do our height, S of t. Let's go past 0. Let's go -1. And it didn't go very high. -1 to 2. Okay? So we're going to graph this. I gave you the window just to make it a little easier on yourselves, or else you'll just keep searching for a window. So go to your calculator, and we're going to turn the plots off because we're not using them right now, and clear out anything that you have in Y1. And we're going to enter this quadratic in. So -4.676x squared plus 3.758x plus 1.045. Okay. And then make sure with every problem you got to change the window. So we're going to change the window from 0 to 1.5 and then -1 to 2. And let's see if that shows the whole story. It does. Okay. So as you can visualize this, what's happening is it's not coming off the ground. It's, you're throwing it. You're throwing it up, and it's coming back down. Boom. So there it goes, right there. All right, so our first job is to find the maximum height. Now, it's just any old quadratic. Okay, you want to find the maximum height. You would go to second trace, which is calculate the maximum. And then go to the left and hit enter. Go to the right, hit enter. And the maximum height occurs at 0.4 seconds. And the height is 1.8 meters. Okay, 1.8 meters. So that's as high as it goes. We went to second trace and found the maximum of the graph. Yep, you got to go to the left and right, hit enter. Okay, part B. At what time did the ball hit the ground? Okay. What time did the ball hit the ground? Now, there's a couple ways to do this problem. You can use your calculator, okay? We want to find out when y equals 0, when our height is 0. So what I'd like to do is I like to go y equals 0 into y2, and then just find their intersection. Go back to graph, and go over to calculate, number 5, the intersection, and hit enter 3 times, and then it'll tell you when the ball hit. And it's nice to visualize. You see it on your calculator. This is the ground, and that's when the ball hits the ground. So it hit the ground at 1.022 seconds. Very quick, just over 1 second. Okay? All right, and then finally the third part. This is the hardest part. They're going to ask you a couple of questions. What is the velocity at the maximum height? Okay, that's going to be the first velocity question. And what is the velocity at the ground, when the ball hits the ground? What's the velocity then? Okay. So you got to go to the velocity equation. Well, you're like, where's the velocity equation? They're not going to give you the velocity equation. Yeah, but there's a really easy way to find the velocity equation when you're given this. Okay. The velocity equation, v of t, is to take this number, -4 and multiply it by 2. Okay, so what is it? -4.676. Dang it, hold on. 4.676 times 2. Okay, that gives you g. G's a little bit off. It's negative 9.352. Then put a t there, velocity, okay? And then plus, the velocity equation is the initial velocity, which was 3.758. Okay, so you have to find it from your equation. Do you see what I did? No. Right here, this and this, they are related, okay? This is negative 1/2 gt squared. This is negative gt. So I take that 2 and I multiply it by negative 1/2 to get negative gt and then plus v sub 0. We just took the derivative, which you don't know about yet. Yeah. Okay, so what is the velocity of the max height? Well, now I have the velocity equation. I can plug in any number for t that I need. So at the max height, what was t? T was 0.4 seconds. It's right there. So I want to do v of 0.4. So you go negative 9.352 times 0.4 plus 3.758. What'd you get? Yeah, you get 0.0172. It should be 0, right? Do you know anything about physics a little bit? This ball's going up, and when it reaches the maximum height, the velocity is 0. And then it comes back down. And now it's increasing, coming back down. Okay? So then what's it at the ground? Well, we would have to do v of 1.022. So plug that into your velocity equation, because this is asking you what is the velocity. That's going to be in your velocity. When it's asking you what is the height, that's the s of t is height. So v of t is velocity, s of t is height. Now plug in 1.022. So negative 9.352 times 1.022 plus 3.758. Ooh, and you get negative 5.8. And this should be in meters per second. Velocity is a speed, but it can be negative. And the reason why the velocity is negative is because it's going down to the ground. Boom. And it's going pretty fast when it hits the ground, negative 5.8. It picked up all that speed on the way down. It was going, up at a speed, and then it reached 0 velocity, and then it's catching up, and it's going down faster and faster until it hits the ground. All right. Who likes physics?